Okay, so hello everyone. In this video, I'm going to summarize the integrated science topic 11 about force and motion. So let's begin first of all, for the force and motion, you may need to recognize that it's something that you learn in primary school about the speed is equal to distance over time. And based on the changing subject, what you learn in mathematics, in algebra, then you will know changing the time as a subject, then it will be equal to distance and speed. And then distance will be equal to speed times the times. And then you can somehow, if your mathematical skills is not really great, then you can draw this triangle and recognize the relationship of the triangle. So for example, if you want to find distance, then it is equal to speed times time. And if you want to find speed, then it's equal to distance over time. And if you want to find time, it's equal to distance over the speed. And the unit of speed is equal to meter per second. And in mathematics, we have this kind of relationship. 1 over x will be equal to the x to the power -1. And hence we can represent in the sense like ms to the power -1, where m stands for the meter and s stands for the second. And there's also some other possible units for speed. For example, we got the kilometer per second, or we got the centimeter per minute. So as long as it is about distance over time, so any units that correspond to distance over any unit that corresponds to time, then it will be about the unit of speed. Okay, next is about the distance time graph. So for distance time graph, it will be so useful so that we can convert the mathematical relationship in terms of graph. Because we know that the distance over time will be equal to the speed. So in this straight line, what does it mean is that the distance over time is actually the same throughout the line here. So we can say the speed of the object is actually constant, or in other words, we call it uniform speed, meaning the speed will not change. And based on that, we can actually find there are different kind of speed in this graph. So with the blue line here, you can see it is more steep, it's steeper than the others. So we can base on this slide to see that the speed is actually higher than the red one and the orange one. So based on that, in mathematics, we can call it a slope. Okay, so slope, the greater slope, it will be steeper. So that this is also a way for us to show the different constant speed here. And based on these two information, let's take a look for another graph. It's about this one. So it means that at the beginning, there's a constant speed from time 0 to time equal to t1. And after that, the object will actually stop moving and you will got an horizontal line here, meaning that no matter any time after t1, the distance traveled by the object will be the same. So it means that the object stopped moving. And these 2 points are used to describe the graph. And then for this graph, you can see that at first we get a constant speed from t equal to 0 to t equal to t1. And after that, it moves with a lower constant speed after t1. So you can see the slope is actually decreased. Or somehow can say the speed after t1 is actually smaller because the distance over time is actually smaller after t1. And for this graph, it is about, you can see that it become curvy here. So it means that the object is moving with a decreasing speed. Okay, decreasing speed, because from different time, we can also find the speed at different time here, and you can find that the slope is actually decreasing, so meaning an object is actually decreasing in speed. And then you need to recognize some effects of force. For example, a force could help start moving. For example, when you kick a ball from rest, then the ball will actually travel along the distance, then it start moving. It will also speed up or even slow down. For example, you apply brake to a car, then the car will actually slow down. When you apply brake, that's actually a braking force and comes to stop, etc. So this is actually about the effect of force. So first of all, this first 4 point is about force can change the speed of an object. And then it can also change the direction of the motion of an object and also change the shape of an object. And it's about the measurement of the force. We can measure force by using spring balance with the unit called Newton. We use capital letter N. So make sure that it's capital letter. And it's a spring balance. And if you do the experiment, you may recall that at the beginning of the experiment, you may need to make sure that the pointer is pointing at 0 at the beginning. Otherwise, the instrument may not be really accurate. The reading may not be really accurate. So you need to adjust the initial at the beginning, the starting point at 0. For force, there are 2 kinds, with one kind called the contact force, and the second one is called the non-contact force. So for the contact force, it's about the forces that act with direct contact on objects. For example, friction, air resistance, and also force like how you pick an apple, you use your hand, you hold it, and you're contacting with the hand, and this is what we call a contact force. So it's rather straightforward. If you contact something to apply the force, then this is a contact force. So even for air resistance, it's actually contacting with air. Without air, there's no air resistance. And then it's about non-contact force. It means that there's a force, it will still apply even without direct contact on each other. So what does it mean? It's like, for example, force of gravity. Even if you're not touching the earth, you will still experience the force of gravity. And same as the magnetic force, okay, even if the magnets are not touching each other, the magnets will still experience the magnetic force. Either it's attractive or repulsive force. And then it's about electrostatic force. So for electrostatic force, it's something like if there's a positive or negative charge, they will attract to each other. If it is same charge like positive and positive, negative and negative, then they repel each other. And then it comes to the balanced force and unbalanced force. So for balanced force, it's actually, for example, in this picture here, we've got the left-hand side force and right-hand side force. Both are equal in size, but in opposite direction. So the bus will not move. If the bus at the beginning is not moving, then it will keep its original state and just not moving. But if the bus is actually moving at a constant speed, then if we apply a balanced force on it, the bus will also move with constant speed. And second is about unbalanced force. Like here, you can see the arrow is shorter here, meaning that the force on the left hand side is smaller than the force on the right hand side. Although you are not really necessary to draw the force diagram in this case, like you don't have to present a shorter arrow, mean that it is a smaller force. Okay, so in this way we can see that generally the right hand side force is greater than the left hand side force, and hence there's a net force acting on this bus to the right. So if that's the case, then the bus will actually move along the direction of the net force, which is moving to the right hand side. And next is about using free body diagram to represent the direction of force and also the kind of force acting on an object. So for example, a helium balloon remains at rest in the air as shown here. Show a free body diagram for the helium balloon at the moment. So you can see the upthrust and also the weight here. Because just in case that if this balloon is actually moving at rest, like it's not moving, okay, so just staying at in the sky, so the upward force is actually equal to the weight of hot balloon, so as to balance it. But just in case if the balloon is actually moving upwards, then you can say the upthrust is greater than the weight of hot balloon. Same case applies to that. If the helium balloon is moving downwards, then you can say the weight is greater than the upthrust. So we'll use the free body diagram to indicate the kind of force and also the direction of force. And the second case is about like if a tower crane is hanging a box by a cable. So in this one, it's actually indicating that here got a tension upward force here, and the weight of the object will have a force pointing downwards. Okay, and then let's come to the force of gravity. So force of gravity is actually like a force acting on an apple by the earth. And like in this picture, we'll draw it in this way. The arrow starts from the center of the apple pointing towards the earth. Normally it's downwards, okay? And attraction from the earth, it is also pointing towards the earth center, and it is non-contact force in nature. For gravity and mass, the force of gravity not just keep an apple to the center of the earth, it will also attract to the moon and making it moving around the earth. So for example, an object of a greater mass is pulled by the greater force of gravity from the earth. So meaning that for an object being attracted, the force of gravity depends on the mass of the object. If the mass is greater, then the force of gravity will be greater. So one example will be the force of gravity experienced by me will be much smaller than that experienced by the moon, because I'm much less mass than the moon. And when we compare weight and mass in science, we will strictly separate them into two different terms. For weight is actually referred to a force of gravity, which is in Newton, and mass is about the amount of the matter, amount of particle in the matter, and we'll use kilogram and gram. So if a block has a mass of 3 kilograms on Earth, its mass will also be the same in the moon. And if a block has weight of 30 Newton on the Earth, then its weight on the moon will be less than 30 Newton. And that's probably because of the force of gravity acting in the moon will be different from that acting in the Earth. And it's actually about 5 Newton in this case. And after that, it's about friction. So friction is something that like you rub your hand and then you experience a friction. And if you present free body diagram on a box, then friction can be drawn in this way, a pushing force in this side, and then the friction will be opposite to its opposed motion of the box. Okay, and given that if the pushing force is actually equal to the friction, then the box will not moving because there's no unbalanced force acting on the box. And friction is actually a kind of contact force, and it will oppose the motion, the direction of the motion. For weights that reduce the friction, we can add lubricants like the WT-40 that somehow we can smoothen the door if you got this experience. And we can use air cushion, like connect a balloon and then to a CD, and with the airflow there, it can reduce the contact, somehow reduce the friction between the surface. And also with the using the rollers, for example in the spinner there, you can see there's actually lots of tiny roller that will help reduce the friction. And for air resistance is something very similar, that when a force, it is a force which opposes the motion of objects moving in air, but then the shape will also affect the air resistance. So for example, in this diagram, you can see this is somehow like a streamlined shape that we can help to reduce the air resistance. Okay, and next part I will talk about the action and reaction pair. So if you're interested to continue, you can see my video part 2 about the summary of force. So please help to subscribe my video and go on watching the part 2 video. Thank you.